So today we're going to talk about unit analysis. Unit analysis is used to convert one unit of measure to another. In a unit analysis problem, we place measurements into fractions, multiply, and then eliminate the unwanted fractions. So here are the steps to unit analysis. Determine the conversion factors. Write the starting factors with units included as a fraction. Write the ending factor with the units included as a fraction. Arrange the fractions so they can be canceled and multiplied in one step. Cancel the unwanted units, and then perform the calculations. So now we're going to show you some examples.
Okay, so for example 1, we're going to look at changing months to years. That's a pretty realistic example. I think most people want to know. So we're going to change 45 months into years. Now our conversion factor is pretty simple. It's basically, how many months go into 1 year, and that's 12 months is equal to 1 year. So we're going to write it as a unit analysis problem. 45, label that as months for 1. Then 1 year is equal to how many months? 12. And since we have two common units here, we can cross them out, and you're left with 45 over 12. And here now we just divide 45 by 12. And I have my calculator with me, but that is equal to 3.75 years, or 3 3/4 years. And that's our answer. Pretty easy. All right, now we're going to see another problem.
So our next problem is going to be converting yards to feet. So the conversion factor is 1 yard equals 3 feet. So we wanted to change 25 yards to feet. Feet, not feets. So what we're going to do is we're going to put 25 yards over 1. And we're going to multiply that by 3 feet, because there are 3 feet in 1 yard. So 3 feet to 1 yard. And we put 1 yard on the bottom to cancel out these yards. And since now you have 25 times 3 feet, and that is essentially 25 groupings of 3, it equals 75 feet. So there are 75 feet per 25 yards. So yeah, there's your second example there.
All right, here is our third example. It's another kind of easy one. It has to do with the metric system again. We want to change, how about changing 4 meters into yards. Now, we need to know how many, our conversion factors, we've got 2 this time. That makes it a little bit trickier. So, we got 36 inches in 1 yard, And then we have 39.37 inches, and I just looked that up for 1 meter. Alright, so now it's time to do some unit analysis. I'm going to write 4 meters over here. 1 to 39.37 inches to 1 meter, which is part of our conversion factor up here. And we're going to write 1 yard to 36 inches, part of our conversion factor. And now we can just cancel out these inches here. Oh, sorry. Can't forget those multiplication signs. So now we can cancel out meters here also. And now we are left with, if you multiply 39.37 by 4, you end up getting 157.48. And then you still just have 36 on the bottom. You want to keep your yards up here. Now if you multiply 157.48 by 36, you get 4.37 yards. You want to make sure to include your unit here, else it'll be pretty ambiguous. Alright.
Fantastic.
Okay.
Now we're going to do a little more complicated problem. If you've ever wanted to know the thickness of aluminum foil, here's your chance to find out. So 1 package of foil equals 100 square feet. So that's the area of the whole roll of foil, and it weighs about a pound. So we're just gonna say it weighs a pound because, for the sake of this problem, why not? And then the density of aluminum equals 2.70 grams per centimeter cubed. So that's pretty much a conversion factor right there. You have 2.70 grams for each cubic centimeter. So we're going to find the thickness. So first we want to find the volume in the whole package. We already have the area, but now we need the volume. So we're going to take 1 pound, how much it weighs, and multiply that by how many grams there are in a pound. So there are 453.6 grams per 1 pound. And then we're going to multiply that by 1 centimeter cubed over 2.70 grams, because, as I said before, 2.70 grams in 1 centimeter square or cubed. And I'm going to do those calculations real quick. We're going to cancel these units. We're going to be left with 453.6 grams. Then we're going to cancel these units and divide 453.6 by 2.7. And that will give us 168 centimeters cubed. And that is the volume of 1 package of aluminum foil. But we're not done yet. So the volume, the way we get volume is length times width times height. And what we want is the height, which is the same as the thickness. So we already have the area, that's length times width. So the area is 100 feet squared. First, now we have to convert this to centimeters squared. So 100 feet squared. We're going to multiply that by 12, 12 inches, because that's how many inches there are in 1 foot. And then we're going to multiply that by 2.54 centimeters, because that's how many centimeters there are in an inch. So basically we're converting from feet to inches, then from inches to centimeters. And so we're going to cancel the feet and multiply this 100 by this 12. Then we're going to take that answer, cancel the inches, and multiply that by 2.54 centimeters. So in the end, we are left with 9.29 times 10 to the 4th centimeters. So that is equal, or that is the area. So that's the same as 100 feet squared, obviously. So now, to find the, now we can use the volume and multiply 9.29 times 10 to the 4th centimeters squared times the height to find the height, which we don't know yet, but we do have the volume, so then we can solve this algebraic. So 9 meters squared times the height. So we divide by the area. And then we will, the height is going to equal 168 meters cubed divided by 9.29 times 10 to the 4th centimeters squared. And then we're going to multiply that by 10 millimeters, because that's how many millimeters there are in a centimeter, and that's what we want our final measurement to be in. So we cancel these centimeters, multiply this 168 by 10, and then divide that by the area, and that all equals 0.018 millimeters. So we can round that and the thickness of aluminum foil is 0.018